Well, we'll get things started here right away. Hi, folks. I am meteorologist Max Saparis. Thanks so much for joining us here on Clean Lakes 101 Science Cafe. I'm a meteorologist here at WKOW. You can catch me weekday mornings, 4:30 to 7, Wake Up Wisconsin, and during Good Morning America as well. Proud to sponsor these events, and we'll be with you every single month for the Science Cafe. Busy schedule on deck. 2 UW engineering student groups going to be speaking with us today for their senior capstone projects. Both prioritize the lake health with community placement in mind. So an interesting set of projects. Our first group will present for 20 minutes. That'll take us to around 8:20. Take 10 minutes of questions, and then we'll hear from our second group. So go ahead early on during the presentation, be coming up with some questions. And you see the Q&A button at the bottom of your screen in that green. Click that, or next to the green icon, and click that, and we'll be able to get to all those questions, hopefully. And then we'll have time for the second group's set of questions as well. Now, before we start, handing things over to Kyle George, works for Johnson Financial Group. He'll be telling us a little bit more about the Capstone program and is here to introduce our first student group. Good morning, Kyle.
Morning, Max. Thank you. Before I hand things over to our first student group, I want to thank the sponsors that make Clean Lakes 101 Science Cafe possible. This month's monthly sponsor is C.G. Schmidt, which also helps fund Clean Lakes Alliance involvement in the UW Capstone program. So thank you, C.G. Schmidt, for supporting this year's Capstone students. Along with Johnson Financial Group, First Weber is proud to present these talks each month, and our supporting sponsor is National Guardian Life Insurance Company, and our usually hosting sponsor is the Edgewater. Our production partners are the University of Wisconsin Nelson Institute for Environmental Studies and the UW Extension. So thank you again. A little bit about the capstone projects. So Senior Capstone Design is a required course for all civil and environmental engineers at UW-Madison. With the guidance of professional mentors, students use the knowledge and interpersonal skills they have gained through classroom and work experience to create effective solutions to real problems. It's important to remember these presentations are student projects, not actual projects in place. However, it's our hope and intention that the designs could serve as inspiration for potential real-world projects sometime in the future. Clean Lakes Alliance has worked with the students throughout the semester to set the vision for the projects. Our first group completed designs, that looked at revitalizing a portion of Wingra Creek along Plaenert Drive. Chaz Cummings is graduating in a few weeks with a degree in civil engineering. Michael Verveld is also graduating in a few weeks with a degree in civil engineering. Nora Rickman, who's also joining us, will also become a civil engineering major, graduating in a few weeks. And Matthew Humbert is set to graduate this spring with degrees in geological engineering, geology, and geophysics. And again, as Max said, please submit your questions early by using the question and answer function so we can make sure we get through as many as possible. So thank you very much. And now I'm going to hand things over to our first group to present their project. Take it away.
Hello, thank you for attending our presentation today. We'll be talking about the Plaenert Drive and Wingra Creek revitalization. So I'm going to start with a little brief outline of our presentation today. First, I'll give a team introduction, and then we'll look at the background of the project, the location, and then we'll show you the design that we have come up with for this project. So I'm Chase Cummings. I'm the project manager and structural engineer. Next to me is Nora Rickman, who is the environmental engineer. Then we have Michael Verbelde, who is the construction engineer, and on the end, Matt Humbert, who is the geotechnical engineer. So once again, I'd like to reiterate that we are a capstone course at UW-Madison. It's a student project. We do share a vision with Clean Lakes Alliance that the waterways are the center of Madison, and we really like to better them and put them at the forefront of the community. And we also, for this project, shared a lot of Clean Lakes Alliance's goals, such as improving the water quality, making the lakeshore more sustainable, having greater access to the waterways, and improving placemaking.
This is a map of the project location. We can see highlighted in purple is Plaenert Drive, which is the road of interest for this project. Wingra Creek also runs through this area as shown in blue. To the north of the creek is West Wingra Drive, and to the south is Plaenert Drive. So having two through streets border the creek like this makes it difficult to access and enjoy this waterway. So Plaenert Drive will be abandoned and reconstructed into a park setting. There are many properties along Plaenert Drive that use this road as the primary access to get to their business. So there will be an alternative road connection designed so they can still have access to their property. To the north of Wingra Creek, there is a bike path. This carries high commuter traffic, so it's traveled at high volumes and high speeds. So there will be a multi-use path installed where in the future park that will extend from Fish Hatchery Road to Beld Street, and the park itself will go from Fish Hatchery Road over to South Park Street. Now we will do a flyover of the existing corridor. We can see where Plaenert Drive is in comparison to the rest of the city of Madison. When we start this walkthrough, we will go over on the west side, beginning at the intersection of Fish Hatchery Road and Plaenert Drive. When we fly through this area, we can really see how close these roads are to the creek. They almost block off this creek and make it very difficult to access this waterway. And you can also see the minimal amount of green space between the creek and the road itself. The road coming up next is South Park Street, where the park will end. And the road next to it is Beld Street, and this is where the multi-use path that is being added into this park will end. These are some street level views of Plaenert Drive. The photo on the left is the west end of the project. This is right after the intersection of Fish Hatchery Road and Plaenert Drive. The photo on the right is if you're walking east down this street. In these photos, you can also see the minimal amount of green space between the road and the creek itself, and the driveways of the business owners that use Plaenert as their primary access. Here on the left, we have another view of Plaenert Drive if you are walking further east, and the photo on the right is the east end of the project, right before the intersection of South Park Street and Plaenert Drive. And if we focus our attention to the photo on the left, this is what we see when we look down this corridor right now. After this project is completed, the green space will extend all the way over to the sidewalk, and when we look down this area, we will see people in the environment interacting together in a sustainable way. Some of the goals of this project include developing a green space with amenities. This will be done through abandoning Plaenert Drive and reconstructing it into a park setting. Maintaining access to property owners is very important since a lot of them use Plaenert Drive as their primary access. So there will be an alternative road connection designed so they can still access their property. The value of Wingra Creek will be highlighted through maximizing the green space next to this area and making it easier to get to this waterway. And lastly, the water quality will be improved mostly through mitigating runoff that goes into the creek, which we will discuss more in our final design. Some constraints of this project include environmental concerns. There is nutrient and contaminant runoff that goes into Wingra Creek. There is native habitat all around the creek that must be maintained and enhanced. This photo on the right shows the property lines in red of this area. So there is privately owned land that is a design constraint. There are existing utilities in this area, such as storm, sanitary, gas, cable, and electric, that are also a design constraint. There are regulatory conditions that must be met, such as meeting the DNR codes and standards and the City of Madison standard specifications. And lastly, there is a budget to this project of $3 million.
So with those project goals and constraints in mind, we as a team were able to develop a final design solution. We believe this design solution not only meets the needs of Clean Lakes Alliance, but also the community as a whole by placing the waterfront as the center of the community. So in this design solution, we focused on developing the green space while also providing a alternative design of a roadway. This roadway can be seen on the left end of the project. This roadway extends off of Fish Hatchery Road, where it then will transition into a cul-de-sac. This cul-de-sac will provide access for turnarounds such as buses and vehicles that will be accessing the middle school. Coming out of the south end of this cul-de-sac, the roadway that will then continue around an existing parking lot before then turning east to access all the businesses in the region, maintaining access to all of them. Also on the west end of the project is a non-motorized boat launch. This boat launch will have a pea gravel driveway that will then attach to the alternative roadway for small vehicle access to launch canoes and kayaks into the creek. We believe this boat launch is very beneficial for the local middle school, as they frequently like to launch kayaks and canoes into the creek itself. Coming off of the east end of the cul-de-sac is the pedestrian walkway. This pedestrian walkway will extend across South Park Street all the way to Belt Street. It will also provide access to 2 viewing boardwalks that overlook Wingra Creek. These 2 viewing boardwalks provide an opportunity for park visitors to get up close and personal to the wildlife in the creek, as well as the existing habitat that will be placed there. Also throughout the park is 2 rain gardens. These rain gardens are dual purpose. Not only do they provide a region for plants and animals to live and provide aesthetic beauty, but they also will be treating stormwater runoff, not only from our park creation, but also from existing lots such as asphalt pavements. Also throughout the region is local art. This local art will highlight not only the history in the region, but also local artists throughout Madison. There's also ample seating that is throughout the region. Lastly, along the creek itself, there are duck houses. These duck houses will attract ducks such as mallards and wood ducks to the region, which provides habitat for these animals and also provides viewing for park visitors. Here's a more detailed, back one slide, please. Thank you. Here's a more detailed visualization of the final design solution. So this is the view looking southeast towards South Park Street. This is one of the main viewing boardwalks that is within this design. This design with this viewing boardwalk will provide access for park visitors to directly look at the animals and habitat that are within the creek, which highlights the value of Wingra Creek to this entire region. In the upper left-hand portion of the image, you can also see visualization of the rain garden. Once again, like I said, these rain gardens not only provide aesthetic beauty, but they also will treat stormwater runoff from filtering contaminants and pollutants before the water is then discharged into the creek. This is a view of the second viewing boardwalk. This is looking west. In the upper right-hand portion of the screen, you can also see the non-motorized boat launch. This non-motorized boat launch will provide direct access for park visitors to access Wingra Creek, whether that be for kayaking or canoeing. This viewing boardwalk also will provide access to see any animals that are in the creek, such as the wood ducks or mallards that would be attracted through the use of our duck houses. This is a view looking west down the entire designed corridor. As you can see, the pedestrian path meanders back and forth, which provides up close viewing of the creek in some portions, while deviating away from the creek in other areas. Here you can see the first viewing boardwalk that I outlined. The second viewing boardwalk cannot be seen because that is further down in the project. There's also ample green space within the region to provide areas for relaxation, as well as shade and activities. Here's some attributes of the final design that we would like to highlight. So in the upper left-hand portion of your screen, you can see what the rain gardens would look like. So not only do these provide aesthetic beauty, they also serve a purpose of treating the stormwater within the region. In the upper right-hand corner is an example of the green space that is to be developed. This green space will have areas that are clear with just grass in order to provide areas for activities as well as just relaxing. And there will also be trees for shade and to view, as well as ample seating. In the lower left-hand portion of your screen, you can see one of the viewing boardwalks. These viewing boardwalks will also have educational signage along the railings. This educational signage will educate park visitors on not only the wildlife within the region, but also some of the history and the plants. In the lower right-hand portion of your screen is an example of the duck houses that will be placed along the creek. This will help bring habitat back to the region by attracting species such as wood ducks and mallards for public viewing.
So keeping in mind that healthy lakes are what bind communities together, we're going to take a look at a couple of the pollutants that threaten water health. So the first major threat to water quality in this area is runoff due to phosphorus. So the primary source of this phosphorus is from the agricultural industry, but also from the fertilizers that we use residentially in our own lawns and gardens. Other sources include pet waste and other animal waste, as well as various types of organic matter, including leaves, grass clippings, and other yard waste. The major environmental effect from this phosphorus runoff is that we've had blue-green algae blooms on Lake Wingra, pictured in the bottom right, over the past couple of decades. So not only do these blooms block sunlight from reaching the lower aquatic plant species in the lake, but they also consume large amounts of oxygen when they die off, which puts immense amounts of stress on the aquatic animal species. The other major threat to water quality is from runoff from chloride. And this is primarily sourced from the road salt that we spread on icy roads on cold mornings such as this. Increasing chloride concentrations within a body of water are known to be toxic to fish, insects, and amphibians. If you look at that graph on the upper right, you'll see each of those lines represents a different lake within the Yahara watershed, where the blue line represents Lake Wingra, which, as we know, feeds Wingra Creek. The concentration in Lake Wingra is approaching 120 milligrams per liter. And according to the Canadian government, a concentration of 120 milligrams per liter is estimated to be toxic to 5% of aquatic species. Other effects from chloride runoff are that chloride interferes with a plant's ability to absorb moisture through its roots, and it also alters soil chemistry, which can stress soil microbes. Moving on to the more social aspect, the runoff from these pollutants have caused beach closures on Lake Wingra over the last decade. One of the causes of this is from cyanobacteria, which are those blue-green algae blooms. And so these are large bacteria colonies that are not only unsightly and unhealthy if consumed by humans or animals, but they decrease the ability for people to interact with the water and each other through the water. The other major culprit of these beach closures, which is pictured as the blue line in that graph, are from E. coli outbreaks. If you're unfamiliar, E. coli is a bacteria that is from the digestive system of mammals and birds. And E. coli often finds its ways into a body of water by running off of impervious surfaces, such as one we might have as Plaenert Drive, and where it's allowed to directly drain into storm sewers and then something such as Wingra Creek. And when you have E. coli, it's often indicative that there may be other dangerous pathogens as well. So in order to quantify the environmental impact of our rain gardens, we used a software tool called WindSlam V10. What it does is it lets you input your parameters of a rain garden, like we have in the bottom right, is what we used for our westernmost rain garden, in accordance with the Wisconsin DNR rain garden specifications, which is pictured in the bottom left. And the way we modeled it was by considering before our project, before the rain gardens, where we have Plaenert Drive and the sidewalk there, and then comparing it to after the rain gardens, once the green space has been revitalized, where those spaces have now been converted to green space. And the picture on the upper right is to give you a scale of generally how big our rain gardens are going to be. After running the program, we get annual reductions for several environmental concerns. And we get a range for these reductions because we considered a best case scenario, which is if we could direct all of the water that was over Plaenert Drive into our rain gardens. And then a worst case scenario is if we could only direct an adjacent 50 feet on either side of the rain gardens to infiltrate through our rain garden. So the first reduction we got was in runoff, and that was reduced by 32%. So this figure represents the decrease in impervious surface that we have, where now we have, instead of Plaenert Drive and the sidewalk running directly into a storm drain and into Lake Wingra, we now have that water infiltrating through green space and our rain gardens and then making its way to the creek under the surface. The second one is total suspended solids, which was reduced by 29 to 33%. So this is a measure of the urban contaminants, organic debris, and other very fine particles that are able to flow within water. And so we've reduced these that would also run through a storm sewer and into Lake Wingra. And finally, we have our phosphorus reduction, which was 22 to 33%. And this, once again, is a function of less organic debris that would be collecting on the streets and the storm sewers that no longer is draining directly into Lake Wingra, or Wingra Creek, excuse me. Looking at the more aesthetic aspect of our rain garden, we wanted to select plant species that not only attract a diverse biology of pollinators, insects, and other animals to our rain garden, but also ones that bloom at different times of the year so that visitors can enjoy our rain gardens throughout the growing season. Other considerations were that we wanted to select plants that are tall enough to stand out in our rain gardens because they do sit about 2 to 3 feet below the surface. And also we have a considerable amount of shade in the region just from the trees. And so we wanted to select plants that would thrive in a partial sun environment. And finally, we want to ensure that not only are visitors benefiting from the clean water that our rain gardens are facilitating, but also that they understand the process of a rain garden. And so we want to create educational signage such as this, which would allow visitors to understand that not only is the rain garden mitigating contaminants, but it's also impacting things such as ecology and erosion. And we want to be sure that things such as this are accessible to everyone, regardless of background. So we want to make sure that something like this can be accessed in multiple languages, which could be as simple as adding a QR code, as you can see on the bottom of the sign, which would link a translation and would allow everyone to learn about sustainable urban infrastructure.
Once again, we'd like to thank you for attending our presentation. We'd also like to thank Clean Lakes Alliance for the support through this project. And we will now be taking questions through the Zoom chat.
Excellent. Thanks so much to our Wingra Creek revitalization crew. A lot of interesting pointers. Of course, if you know the Madison Metro at all, that's, I would say, a highly underutilized spot. So that would be a really interesting project to see undertaken. So if you have questions, go ahead and put them in the Q&A category on the bottom of your screen. Looks like we have about 7. Also catching one in the chat too. Thomas mentioning we don't want to forget about fishing opportunities on the boardwalk and the overlooks that would be provided, especially for handicap fishing areas. So an interesting pointer as well, not necessarily a question, more of a comment. On to the questions now before we kick off our next group of presenters at 8:35. Someone mentioned, can you provide a brief summary of pollutant reduction for stormwater runoff to Wingra Creek? So again, specifically for that corridor, what you guys are thinking.
Yeah, so the pollutant reduction is going to come from the fact that we no longer have these streets and sidewalks where sidewalks, we kind of touched on that you can get animal waste and pet waste that can run over these impervious surfaces and directly into a storm drain, where same with Plaenert Drive, that would have urban chemicals and stuff that would run also directly into a storm drain, where when we have the green space, those chemicals interact with the soil microbes and attach to soil particles. And so by the time that water is still going to make it to Wingra Creek eventually, but it's going to be filtered, and especially it's going to be filtered through our rain gardens, which have soils that are engineered specifically for contaminants. And so both the green space and the rain garden would work to remove those contaminants.
All right, thanks for that. Katie asking, what do we envision the park surface to be? Is that going to be mainly grass outside of those rain gardens you already mentioned?
Yeah, so the entire green space region will be mostly a type of grass in order to not only provide like a nice surface to relax or do like say yoga and stuff like that, but also, you know, that is safe and luscious for small kids and dogs to be on.
All right, thanks for that. Let's see what next here. Also from Katie, does the design manage the shore, or how does that design that you have manage the actual shoreline? Are there buffers that are going to be installed and maintained? So I guess this is an erosion type based question.
I can take that as well. So we're trying to keep as much of the natural habitat along the shoreline as possible. Currently, there is a lot of natural grasses and natural habitat buffer that currently exists along the shoreline. So we're going to try to keep as much of that in place as we can. We will also install some of that in certain regions along the shoreline where it is currently lacking, or where we will be doing work, such as around the viewing platforms and the non-motorized boat launch.
Okay, and that's pretty much Dan's question too. He was wondering, other than mowed grass on that graphic you had displayed, what that buffer would look like. So I think we took care of that. Thank you. Moving on to the next question. Where can people park to access this possible new strip? And especially if you wanted a boat launch, like with kayaks, like a small boat launch, is there going to be this setup? And also, second question, could there be, oops, it just popped away. Second question, again, so first question about kayak launches. The second question, is there going to be seating on the boardwalks?
Yeah, so there will be seating along the boardwalks. I don't know if the visualizations were able to come through to completely show that, but there will be seating on the boardwalks because clearly it's a nice area that we'd like people to stay in and to actually view all the wildlife that amenities such as the duck houses will bring there. As for the parking, we are keeping all the current parking that currently exists within the region. So on the east end, there is ample parking. On the west end, near the non-motorized boat launch, since the alternative driveway access that currently comes off of Plaenert Drive to access the businesses will not be in use anymore, this area will be converted to parking. So we will be actually adding additional parking on the west end of the project to access that and to facilitate the extra pedestrian traffic that we expect in the region.
Okay, I think you covered that quite nicely. Chuck is asking, have you guys addressed the traffic volume on Plaenert Drive in terms of the effects of turning a through street into a cul-de-sac? So sort of more of a road engineering question here.
So actually, that's a great question. But for this project, we were told that a traffic study has already taken place and that we would be able to remove Plaenert Drive. However, we still did want to provide access to those business parking lots. So we thought we didn't want their land that they paid for to go to waste. So we added a alternative roadway for them to still get to their parking lots. But as far as traffic volumes going through there, we were told that there's a study done.
Okay, so a third-party study on that. Greg asking, given the green space is accessed primarily by walking and biking and the cul-de-sac for non-motorized boat access, is the assumption that primary users of this park are going to be local residents and business employees?
Yeah, absolutely. That's kind of the intentional goal is we want to, as Clean Lakes Alliance does as well, we want to highlight the value of these waterways to the local community. So we're expecting, the local community to really utilize this space because we believe it is underutilized at the moment due to some of the constraints that we pointed out, such as roadways on both sides of it and limited green space. And as far as the businesses go, yeah, we believe it'd be an excellent opportunity for, say, during a lunch break or get-togethers for business owners and employees to come out and enjoy the new green space.
Great. Sharon asking, any thoughts about dredging the creek and what that could look like?
Yeah, so we actually thought of that in one of our design alternatives that we presented to our client. We didn't want to alter the natural ecosystem in too many ways. The creek was actually dredged earlier in the 1900s, and that was to straighten it and deepen it. We thought of it as a team to maybe actually fill it in certain areas to meander it. But as I said before, we kind of want the habitat to be restored within the region, so we didn't want to disrupt it any further. That's a great question, though.
Yeah, and you're getting a lot of praise here in the Q&A. A lot of people appreciating this project that you undertook and appreciating the good explanation. So Katie, final question here. Looks like Paul asking a question here too, but we'll start with Katie and then we'll go to the new presentation. And the question from Katie, what is the current of Wingra Creek look like? Is it channeled? And would you would your design change the structure of that creek? So kind of going in conjunction with that last question.
Yeah, so also, yeah, it parallels very nicely with the last question, actually. So currently it is a straight semi-channelized creek. It's natural banks on both sides. It is roughly 8 feet in depth, we believe, in most areas. And it has been already dredged and straightened, as I spoke to before. We're going to try to limit as much disruption in the creek as possible. So the foundation piers for our viewing platforms will be not placed in the creek. They'll actually be placed on the creek bank. And for the non-motorized boat launch, that will most likely be a floating structure that will be anchored to the bank rather than the floor of the creek.
Interesting. So one final question going to come from Paul. I think it's a good summary question, so we'll take this and then move on. And again, thanks so much for your presentation. The question being, what do you think is the most difficult part of this project that's being undertaken?
Yeah, I'd probably say, since it's the most expansive and there are footings and it's near a high groundwater level table, probably the viewing platforms. We believe that those will be the hardest to construct, as they most certainly were the hardest to design. But also with that in mind, we wanted to take into account the various cultural backgrounds and types of people that would be visiting the park. So that also factored into all aspects of our design. But otherwise, to answer your question directly, yes, I would say the viewing platforms would be the most challenging portion.
Okay, we still do have 2 minutes, and we did get one late question here from Beth asking about the plants that we have seen planted near Warner Park for birds. Are we going to be maybe seeing that to increase natural habitat along Wingra Creek? Is that part of the plan?
Yeah, so that list of plants that I threw up were just a few of the many options we could do. Absolutely, we would love also community input on things that they want to see, because this is for the community, this isn't for us. I mean, we are part of the community, but yeah, absolutely. We're going to choose a variety, or we would choose a variety of plants that would attract birds, insects, beetles, anything that plays into the ecosystem and the water cycle. And we just want people to be able to really get immersed in the environment when they're at this green space, and see something that they don't always see, maybe walking around the rest of Madison.
And is wheat included in that? Beth is getting specific on species types.
You know, I did see that as an option when I was going through some of the plant species. I'm not sure if that would do as great in a pretty shady green space that we have. So I'm not exactly sure about wheat, but I do remember seeing that from the Wisconsin DNR suggested plant species for a rain garden. They definitely have pretty good root systems and grow tall enough that would make it look good for sure.
Yeah, so it does sound like it comes down to the canopy being an issue. So thanks to all of our viewers for your questions, and thanks so much to our Wingra Creek revitalization crew. Thanks for the work you're doing, and hope to see this coming soon. Moving on now, I would like to introduce our second group. They're working on another project for Madison to bring a little more synergy to nature and our community that we live in. And this project is specifically to redesign John Nolen Causeway to connect Madison and the lakes, of course. Quick note, John Nolen Drive project currently in the public input phase, and the actual project will start in 2026. So we're just in the discussion phases right now. And that's why we're bringing it up. It's a great timing for it. So the project would serve as inspiration for any public input on this project. So if you have input on it, you can actually check the City of Madison website for info sessions on that, because again, open to the public. So that'll be interesting to join. So Riley Hughes, he's a geological engineer student graduating this spring. Freddie Koth is a civil engineering student graduating also actually at the end of this year. Brandon Hungelsman Skiba, a civil engineer student graduating this upcoming spring. Jordan Knoll, a civil engineering student as well, coming up this spring, graduating then. And Lauren Kienschla is a civil engineering student graduating also at the end of the year. So yeah, students in the senior year finishing up either at the end of the calendar year or at the end of the next semester. Let's turn things over to our students to show how a redesigned John Nolen could be more lake-friendly and community-friendly as well. Now, guys, sorry if I mispronounced any of your last names, but go ahead, take it away.
Hi, thanks so much, Max. Welcome to our final design presentation for the John Nolen Drive Causeway bike and pedestrian improvements. We will introduce our team shortly. A little outline of what we will be talking today. We'll do a team introduction, we'll review the project overview and our goals, and then we'll get to our project design. I'm Riley Hughes, the project manager, as well as the geotechnical engineer. Freddie is our construction engineer, Lauren, our environmental engineer, Brandon, our transportation engineer, and Jordan, our stormwater engineer. We are all seniors at UW-Madison in our final or second to last final semester. Our team name is Students in Transportation and Urban Design, otherwise known as STUD. A little bit more about our project. As you can see highlighted in the image to the right, a little zoomed in photo. In the yellow outline is the exact project boundary of where we are focusing. The location extends in the north from North Shore Drive all the way down to the southern point in Nolan Park. We'd like to highlight Clean Lakes Alliance's goals, which the other team mentioned as well, which include greater public access, improving water quality, better placemaking, and making the project more sustainable. A little vision for the path. We were told to include recreation and increasing safety for cyclists and pedestrians along the path. We'd like to minimize negative impacts of the stormwater, address erosion of Lake Monona, address potential causeway settlement, and last, improve landscaping and amenities for the project. As you can see on the right, those are some current conditions of the path. A little bit more detail. These are some existing cross sections of what the path looks like now. The cross section on top is a typical bridge crossing. We'd like to highlight the train on the left as well as the 2-lane road and then the path on the right. And the bottom image is a typical roadway cross section. Again, we'd like to highlight the railroad on the left, the road in the middle, and then where we will be placing most of our focus, which is the lawn buffer, the path, and again, the lawn buffer in between the path and Lake Monona.
So in order to follow our vision, we've come up with some final design categories that ultimately helped us choose between alternatives. and select the final design. These were chosen because we thought that they were the areas that needed the most improvement along the path. The first being lane design, which pertains to the actual design of the bike and pedestrian path itself. Next is safety, which involves safety for pedestrians and bikers as opposed to the roadway. Piers and outlooks, which will provide recreation and accessibility options for pedestrians and bikers. Shoreline protection, which will address the growing concerns of erosion from wave activity and runoff. Sustainability, which will further Madison's reputation as a green city. Stormwater management, which will help aid in the removal of pollutants and trash that gets into Lake Monona and then further lakes. And lastly, we have amenities which also provide further recreation to pedestrians and bikers. Next slide. So our first design category is the lane design. For our lane design, we've decided to include a 16-foot wide pedestrian-only boardwalk, which will be located in the southern and crescent sections of the path, which cover about 50% of the project length. The location of this boardwalk can be seen in the furthest right picture, highlighted in yellow. And along with this, we will have a 2-directional bike path that is parallel to the boardwalk. And in the northern section where the boardwalk ends, the boardwalk will narrow down to a single lane pedestrian path. And this is also similar on the southern end in Nolan Park. An example of what the boardwalk would look like could be seen in the furthest left picture, and it'll be made out of a wood or composite material. And then in the middle picture, you can see a bird's eye view of the orientation of the boardwalk and the path relative to Lake Monona. And you can see that we have moved the bike path and the boardwalk out further away from John Nolen Drive. Our next category is safety. For safety, we have decided to reduce the speed limit from 45 miles per hour to 30 miles per hour on John Nolen Drive. We have also decided to include some cable guard, and this cable guard will be placed in the areas where the boardwalk needs to come back from the water edge towards the roadway because it has to meet the bridge crossings. And this is the areas where the distance between the road and the pedestrians and bikers will be decreasing, and that's where the cable guard will be used. We also will be including some lighting along the path and emergency call boxes. And another aspect of safety is that we have separated the cyclists and pedestrians into their own paths and moved them further away from John Nolen Drive. Next, we have our outlooks. There will be 3 total outlooks along the path. And the first type is the capital outlook, which there will be 1 of them. And it is called the capital outlook because it is placed in a certain location that gives you a perfect view down Hamilton Street at the Capitol building. And then we will have 2 standard outlooks, which will be similar in shape to the Capitol outlook, but smaller. And an example of a 3D rendering of this outlook can be seen in the furthest left picture, and that is Capitol outlook. The dimensions of the 2 different outlooks can be seen in the middle 2 figures. And then the locations of all 3 of the outlooks can be seen in the furthest right picture.
All right, moving on to our next design category is shoreline protection. First, we will be installing riprap between when the boardwalk begins and the steps, which can be seen, the steps can be seen in the figure that's highlighted with the yellow. We will be including concrete steps near Nolan Park. In all, it will be including 164 feet of concrete steps. What we mean by these steps, or an example of them, can be shown at the Memorial Union photo. The steps will provide recreation opportunities as well as prevent erosion of the shoreline. Additionally, we will be including floating bog interceptors, 30 of which in total. Floating bog interceptors are a floating platform of vegetation that eventually connects to the lake bottom through its roots. It will absorb the wave impact to reduce erosion, and it will trap sediment to reconstruct the eroded shoreline. These 30 interceptors will be placed along the entirety of the shoreline. Next, for sustainability, we plan to use local and recycled materials. An example of this is using composite decking for the boardwalk. Next, we will be including no-mow native vegetation between the path and the roadway. This can also be explained as a bioswale, which will help filter stormwater through the soil. Additionally, we will be including solar-powered lighting, which Freddie mentioned earlier. This will include an aspect of renewable energy throughout our project and can be an easy to see sustainable aspect as you're driving or walking down John Nolan. And our last aspect of sustainability is an ultrasonic algae growth control. We'll be placing one of these in the northwestern triangle between John Nolen Drive and North Shore Drive. The algae growth control emits a frequency that blocks algae from growing, which will hopefully reduce the amount of algae bloom growth that occurs in Lake Monona in general. Our next large category of our design is stormwater management, specifically of the runoff from the path. We'll be including bioswales and rain gardens. A rain garden is where water runs through this bioretention soil, which helps retain water from these large storm events. And eventually it seeps through into a drain pipe that runs into the existing stormwater system and out to Lake Monona. This will help remove pollutants that would otherwise directly go into the lake. Throughout the entire project, we'll be including 1,050 feet of bioswale. Next, to move on to the stormwater management, but this time of the road, we will be including catch basins and sumps, which will feed into baffle boxes. A sump catch basin is built into the existing stormwater system. It will allow larger sediment to settle as well as trap oil and grease for removal before moving onto the baffle box. The catch basin and sumps will remove 25% of the suspended total solids, and it will also slow the peak flow from large stormwater events. The baffle boxes are a natural filtration system that will allow sediment to settle to the bottom, as well as keep litter and other materials from entering Lake Monona. It will remove up to 85% of the total suspended solids, nearly 100% of the trash, and 15% of heavy metals. Our last design category is amenities. These are split into a few different subsections, the first being signage. We'd like to include signage that notes the historical significance of the area, path rules and right of way, and we'd like to include an intention of Indigenous acknowledgement of the area. Next, on each one of the standard outlooks, we'd like to include benches, bike racks, waste bins, and emergency call boxes, some of which can be seen below. And lastly, on the Capitol Outlook point, we'd like to include benches, a sundial, an interactive photo space, which allows a phone to be set up with the background of the Capitol and the lake so that you can set up a timer and take a picture. We'd also include a flagpole with the Madison City flag, which can be seen below, which, fun fact, the flag represents the isthmus with the lakes on either side, and the 4-point star in the middle represents the Capitol. And last, we'd like to include local art installation to really connect the community to this area. An example of some local art installation already occurring in Madison is the Utility Box Project. This can be seen by the cow in the right photo. It's where local artists have their designs printed onto vinyl that will eventually be wrapped around utility boxes. This just adds a little bit of aesthetics and improves the natural look of utilities around Madison. As you can see, this is a diagram of the Capitol Outlook with our different amenities. A few things I'd like to point out is the photo stand in the most top left corner. This is where Hamilton Street will be the best viewing point. I'd also like to point out the flagpole in the middle, as well as a sculpture and the sundial located in the center.
Next, we'll be moving on to our animation that we created in SketchUp. And so as we approach the project, we'll be entering in on the southern bank near Nolan Park. So from this perspective, you'll be walking on the banks of Nolan Park, where we'll have concrete steps on the right, and this is the 6-foot pedestrian path. Along the path, you'll see recycling bins, trash cans, and bike racks. As you walk along the boardwalk, you'll see benches for seating, and then on the left, you'll see the natural vegetation and area for the bioswale, as well as the 2-directional bike path directly adjacent to the boardwalk. And then as we approach the Capitol Outlook, you'll see the emergency call box, the statue in the center of the Outlook, as well as the flagpole, and then extra seating for Capitol and Nolan Park visitation. And then as we come away, you'll see the full part of the southern bank of the project on John Nolen Drive in Nolan Park. And then going into more specific design impacts. First, we'll talk about economic design impacts. So this project will promote more local tourism. By expanding the path, it allows for more pedestrian traffic as well as bicycle traffic. And then moving down, we can look at the increase in local economy, especially biking and running sector, to sell accessories such as running shoes, biking helmets, bikes, etc. And then finally, job creation. The added amenities will add for opportunity in order to maintain those, as well as trash and recycling pickup. Next, the environmental design impacts. By promoting interactions with pedestrians in the lake, it allows the community to become more connected to these bodies of water in a very healthy and green manner, to improve sustainability and to revitalize the importance of these lakes to this community. And then building on that, by improving the water quality and doing so safely, we can improve those interactions with the community, with the lake. And then finally, we hope that this design project can act as a model for green technology, not only in the Madison and Midwest area, but also around the nation with cities that interact with bodies of water. And then finally, for general public impacts. So by creating this boardwalk and this bicycle and pedestrian path and improving it will allow for more connectivity between the northern and southern banks in Madison. And this will allow for both economies on those shores to improve and increase foot traffic. And finally, the health and lifestyle. So by promoting activities such as biking, walking, and fishing, we promote a healthy lifestyle and encourage people to get outside and get some fresh air. And then finally, the project schedule. As you can see, phases 1 through 4 have been completed, which involved research, design, and then reports. And the next phase, as stated earlier, won't begin until July of 2025 for bid document release and awarding the bid to contractors and subcontractors. And then finally, phase 6 won't start until March of 2026, where we project will start road and path construction.
That concludes our project. Thanks so much for listening.
All right, that was a great presentation. Thanks for giving us an update on what that could look like. I mean, I drive on that stretch almost every day, and I've always wondered, right at the where you can see down Hamilton, I'm like, why aren't they doing something there to really showcase that landmark? So, I mean, that's a really interesting part of the project. Just my 2 cents on that. We're gonna go ahead and take some questions here. Let me go ahead and get our Q&A. Here we are, all pulled up. We have a few more questions here. There we go. All right, heading to the bottom of the question pool. Let's do it. So I'm going to start off with this question. Anonymous, but here we go. Total suspended solids addressed in the design. Was there any modeling for nutrient reduction? So specific question here.
Yeah, so with bioswales, we are focusing on using salt tolerant plant species that are native to Wisconsin. So these will help to remove some of the chlorides that were mentioned in the previous presentation, as well as remove phosphorus because as the stormwater filters throughout the ground, phosphorus begins to stick to soil particles and then is slowly removed through the plants there.
Great. Also kind of a specific question here, Chuck asking for that sort of side profile view of the different layers of the path. Did you guys look at porous pavement options for the bike path surface?
So porous pavement was an option and it is still an option, but with limited resources in this area, it does seem to be a difficult option to fulfill.
Okay. So
It could be costly too, but definitely something to explore in later design phases.
All right, interesting to point out. Chuck also has a follow-up question. Does the boardwalk boundary go into the lake or is it just along the shoreline? So what does that periphery look like?
So the boardwalk will hang over the riprap part of the lake, but most of the supports and stuff won't go into the lake directly, but overhang the lake.
Oh, gotcha. Okay, so not on that lake, exactly. Okay, next question here. Did you identify any required permitting for this proposed project? And if so, which permit would be the most difficult to attain? Yeah, this is a big undertaking.
So I know there is certain permitting with the DNR and the state when you are building structures over water. So I assume getting a permit for that would be the most difficult from the DNR.
All right. Moving on. Was there any budget sort of topic brought up?
Budget was definitely a major concern at the beginning of the project. We weren't given an exact budget to stay restrained to. We were kind of designing for the stars with also, being realistic about our budget. So no, there isn't a particular budget. I can see in the next few years as this design really starts to become implemented that there be a specific number come out. But for our design purposes, we did not design with a budget in mind.
Yeah, and important to point out, this project wouldn't be undertaken until 2026, so it's still in the very preliminary phase. So probably why they haven't gotten to that part quite yet. Chuck asking, not really a question, but wondering if they're encouraging more so, but I guess the way to put this into a question is, will there be dog waste pickup sites? Those little baggy dispensers that we sometimes see at the parks.
Yes, that's definitely going to be included in our design along with the waste bins. We'll have it separated, of course, so that that's not going into our landfills or anything like that.
Yeah, always a good idea. I always love snagging a few of those for my pups. Thomas asking, looking like you are planning on filling in a significant part of the lake west of the roadway. So one, is that what we're seeing? And two, any thoughts on where you would recreate that open water to provide for flood management? So we still have that square footage of water or that volume there,
So that cross section that we showed, that's two different sections along the drive. One is a bridge section where the road narrows and the railroad separates. It's kind of in that north section where it separates into that triangle that we talked about where the ultrasonic algae growth would be. Because of this, then the roadway comes back. We're not touching that side of the road. That part is not part of our project. We're mostly focused on the bike path. So there will be no filling.
Oh, so okay. So just to confirm, it was just sort of, we were looking at the image wrong. It wasn't that there is any water that's going to be actually filled in, correct?
Correct.
All right. Well, you're talking to the Clean Lakes Alliance folks, and that's why that would be a top of mind issue, right? So Thomas, thanks for having us clarify that. Looks like that's all the questions I have. I'll give, a couple extra minutes here to see if we have any more populate in, but really interesting projects. Both are sites that we know we can do more with, right? And they're also sites that we know can be more environmental friendly, as Madison is so proud of being that way and continuing that in future projects for years to come. So I want to thank both groups that presented today. If we didn't get to your questions, it looks like we did, but if not, you can go ahead and email info@cleanlakesalliance.org and we'll forward that question that you may have to the appropriate group that was speaking on these topics. If you want to rewatch any portions of today's meetings, it should be up on Clean Lake's Facebook page tomorrow around this time. And the next meeting for us is going to be January 12th coming up here. And that is going to be for our Clean Lakes 101 Science Cafe. And the next group presenting next year, really, we'll be talking from New York State on research on how to better monitor and study harmful algae blooms in our lakes. So maybe, again, a better way to monitor than we already have. So an interesting topic coming up. And I know, again, we're kind of going out of order, but I did see one quick little question pop on in. Maybe it was a question, maybe it was just a comment. We'll go to that Q&A section just before we end it here, because we still have a little extra time. We were slating this to end at 9:15. Purpose of so this is a question for our last topics. So maybe they can come back up. The question was, Richard's looking for an explanation again of the purpose and location of the floating bog interceptors, and behind those are you trying to create wetland habitat?
Yeah, so the floating bog interceptors will be installed intermittently along the entire length of the shoreline. And their purpose is to add additional shoreline protection to the project and also promote like sustainability and native vegetation along the causeway. We're not necessarily going to create a wetland habitat, but just for added protection and erosion control.
I do also want to point out that this is a regular or a relatively new technology that they've just started creating. And they have seen increases in wildlife in these. There's a lot of geese that like to nest in them, as well as amphibious groups that like to be there. And personally, as a fisherman, they attract a lot of bass to nest beneath them. So they're pretty advantageous technology all around for a lake.
All right, so just as it is, could be really beneficial. Well, thanks for following up on that last question. Great presentation from both groups today. Again, next one is going to be on the 12th of January, 8 a.m. bright and early. We'll have a group from New York State talking about better monitoring harmful algae blooms and how to record that data. So an interesting topic for next month. Thanks so much for joining us today. Have a great holiday season, and we'll see you back here 8 a.m. January 12th.